So this is the second video I'm going to do on graph theory and terminology of graph theory. So I'm going to draw some vertices here. So I'm going to have A, B, let's put C here and D here. I'm going to join some of those up. So I'm going to join A to B to C to D, and I'm going to join this one back up to A. So let's just label these A, B, C, D. Now what I've got here, first of all, is that I've got a connected graph. That means that if I'm at any vertex, I can go around this and connect to another vertex. So if I wanted to get from B to D, I could go along this way and get to D, or I could go along this way and get to D. Okay, so this is called a connected graph, when I can get to any point from any other. But more than that, because all the points are joined together, I've got a cycle as well. So I've made a cycle by joining up and making up a cycle. And sometimes we see this graph shown as C4, 4 vertices in a cycle. And what I'm going to do is I'm going to actually show you the complement of this graph. So the complement is basically to draw the vertices again, but take away the edges and connect edges that don't meet up here. Sorry, that aren't in there. So A to B was connected with that green edge at the top. And A to D, that was connected with an edge. So I'm going to take those edges away. But A to C is not connected. So I'm just going to connect A and C together. Let's do it in green and keep it consistent. So the edge there, A to C, and B is connected to A, and B is connected to C. So I'm not going to connect them, but B is not connected to here. Now, once again, we don't have to have that one there. And in fact, what I could do is loop it around here to there. Now, with this graph, it's not connected. There's no cycle and it's not connected. I can't get from A to B. I can get from A to C, but I can't get from A to B. From B, I can't get to C, etc. So we've got a connected graph and an unconnected graph. Okay, let's have a look at another one. Let's have a look at a graph which is called complete. So a complete graph. Now the complete graph we denote by using a K rather than a C. So I'm going to look at a complete graph K5. So that means I've got 5 vertices, and the complete part means that I can get to every vertex directly from any vertex. So that means if I'm at this vertex here, I can get directly to this one, I can get directly to this one, I can get directly to this one, I can get directly to this one. But then if I'm here, I can get directly to every vertex in the graph. I don't have to pass through any particular vertices. So if I'm here, I can go directly to each vertex. And that's known as K5, and it's a complete graph. Next, we're going to look at a tree. Now, a tree, very importantly, does not have any cycles in it. So I'm going to look at a tree. So I have vertices here. I'm going to put 5 vertices in, and I'm going to connect this vertex with this one, and this vertex with this one, and this vertex with this one. That's fine. Now I'm not going to connect these 2 vertices together because that would make a cycle, and trees don't have any cycles, but trees are connected. So here I can get to any vertex from any other point. So I can go along here and get to this vertex, or I can go along here. It's fine. But I'm not allowed to close it off by joining these 2 vertices and making any kind of cycle. So it's fine to keep adding some vertices here. If I add another vertex here, I could connect this with this one, or I could even connect it with a nice loopy one like that. So these are trees. Now the final one that we're going to have a look at is called a multigraph. And a multigraph is where there are multiple ways of getting somewhere. So let me explain. Let's draw some vertices. Let's have A, and we'll have B here, and we'll put a C and a D and an E, and let's start connecting some of these up. So I think I would like to connect up A with B. Fine. Let's connect this one up here, connect this one up here. Now at the moment we've got a tree. Now it's no longer a tree. And I'm going to put some extra things in here. So I'm going to connect B to C using another path. And the minute I do that, it changes from being a simple graph to being a multigraph. Further, I could actually add some more on here. So let's add this one up here. And I could go from B and come back to B. So this now becomes a multigraph. So a multigraph is anything where we have multiple loops or multiple ways of getting, say between E and D, I've got two different ways of getting there.